My name's Jeremy Blum. Right now, I'm the Director of Engineering at Shaper Tools, a company that makes handheld robotic power tools. I've been here for 4.5 years, and I'm responsible for all of our electrical engineering and architecture, and I also oversee our embedded software development. But before I was at Shaper, I spent a few years at Google X, where I worked on the electronics and architecture design for Google Glass and similar projects. And back before that, I did a whole bunch of different things. I spent a while working on an LED lighting startup. I spent some time doing electrical design work at MakerBot on 3D printers. I did prosthetics research. I did sustainable building design research and development, home automation systems and things like that. Been kind of all over the place, but pretty much everything that I've worked on, I really enjoy focusing on building products that empower people to make things or express their own creativity in some way. That's what's really important to me, and giving people the empowerment they need to do that. So when I'm not working on an actual product that enables someone to do that, I also am very involved in education and teaching. I've written now 2 editions of a book about Arduino and using that as a mechanism to learn about physics, electrical engineering, embedded software design, product development, and user experience design. These are all things that are really important to me, and I take any opportunity I can to educate younger people, educate aspiring engineers, and work with them and show them the ways that they can use math and science and physics and engineering creatively to do exciting things.
It must be incredibly gratifying to see people using your, educational material or the products that you say enable other engineers. What's it feeling like when people come back to you and say, look, I did that using your product and using the knowledge that you gave through your courses? What does that feel like?
The most gratifying thing I get on any given day or week or month is seeing feedback from people who have either used products I've worked on to make exciting things, whether it be woodworking and artisanal type products, anything ranging from jewelry up to gigantic grand conference room tables and armoires and all kinds of crazy things that are well beyond my own skills to build these things, but built with a product I worked on at Shaper. That's really exciting to me. I get comments and emails and things from people who have read my book or watched some of my videos online maybe, or have seen other projects that I've worked on or used open source software or hardware designs that I've distributed and have built something on top of it. And even more gratifying is sometimes, I'll hear from people and they'll say, hey, I read your book, or I watched one of your videos, or I saw a project you worked on and it was really inspiring to me, and so I decided I'm going to study electrical engineering. And that's a very exciting moment for me. At the same time, I'm stressed out for them because studying electrical engineering is very hard. But I'm also excited for them that I was able to hopefully inspire them in some way or help them find something that they find interesting and engaging that they otherwise might not have. And I think it's the responsibility of anyone in any profession to do some of that, to inspire younger people or people who don't know what they want or need yet, and just need to find the right resources to see, oh wow, this is the thing that really sets off that spark in my head and I am really excited by it. I think there's something like that for everyone, but it can be difficult to find what it is. And when you do find what it is, or when there's good resources out there to help you find that thing or learn about that thing, I think that's pretty exciting. So I'm glad that I'm able to be a part of that for some people.
Right. And in the documentary about Arduino, where we also interviewed you, we talked about that that enablement of sometimes people. You mentioned that sometimes people they don't have the resources, or they cannot really estimate what it takes to actually make something, so they immediately get discouraged because they are lack of information. What would you tell somebody who wants to make things? What do they need from the get-go to get started instead of discouraged?
Building a product, for example, especially one that you want to sell to people or consumer good of some kind, is undoubtedly a complicated, difficult, and expensive process. And there's a lot of parts to it and a lot to learn. And I think part of why people get discouraged from doing that sometimes is they try to go 0 to 60 miles an hour immediately, right? Like going from no knowledge to I have an idea and I need this immediately to be available for sale on Amazon, right? But there's a million steps in between there. And I think understanding what those steps are and taking them at your own pace and working your way up to it and finding, if applicable, the other people that you need to work with to achieve that end goal is really important. And so I think part of educating people about engineering is not just saying, okay, here's how you write this piece of software, or here's what it takes to make a PCB that's going to pass EMI testing, or whatever. These are all parts of it, but another part of it is helping people to understand the multiple steps involved to get to an end product, and that there's prototyping involved, and you have to understand, okay, am I going to sell this in multiple countries? What's involved in doing that? How do I have it handle multiple languages? What is my user base going to look like? What do they need the product to be able to do? And there's no reason why you have to try to jump to the end step right away. And so I think what gets people discouraged sometimes is this feeling that they need to get to a marketable product immediately. And you don't have to. It's okay to start small and to build up your knowledge and to then get to the point where you can maybe be working on something like that. And certainly part of what I try to elaborate on in my book is I'm using Arduino as a platform to teach engineering and software development and product development. But I also try to take a look and do a deeper dive at the science behind some of these things, as well as the business and product development side behind some of the things. So for example, like what does the supply chain look like for an integrated circuit? Why is it so much cheaper to get an integrated circuit that is like a 6-axis accelerometer gyroscope today than it was 10 years ago? And it's because the cell phone market has made those things accessible. Understanding the backstory behind these things and the components that you might use to build a prototype of a product, or the libraries that you might use to write a piece of software, is really useful in understanding that we're all kind of standing on the shoulders of giants. And when you see what those giants did and what they developed, it makes it easier for you to take that next leap up to that next level. And having that understanding is really important if you want to get to that end goal, that initial idea that you had to make a product or whatever it is. It's okay to work your way up to it. And you're going to get discouraged if you try to jump there right away. But if you learn the bits and pieces of it incrementally, before you know it, you'll look back and you'll think about and realize all the things that you've learned and realize how well equipped you are now to do that thing.
So which of the projects that you've been working on in your past was one that you have learned from most? The most challenging one, if you wanna say.
It's hard for me to say one project I've worked on that was the most challenging. I have made, I would say, an intentional effort to challenge myself differently in every project I've worked on. And I'm fortunate in that I've been able to do that. Not everyone maybe has that opportunity. But the product that I work on now, Shaper Origin, it's a complicated and difficult product to develop, but in a very different way from Google Glass, one of the products that I worked on previously to this. Google Glass was all about, okay, you have to make everything as tiny as humanly possible, and it has to be powered by a battery, and the user experience needs to be good, and it needs to maintain wireless connectivity. And Origin is a very different set of problems. It needs to exist in a workshop environment, and it needs to be used like a power tool, which they get pretty abused. And it doesn't have a battery in it, but it needs to be able to work internationally on different types of power and things like that. So the problems are different and challenging in their own different ways. So I have very much appreciated the opportunity to take, I would say, problem-solving approaches that I've learned from previous products and apply them to new products. And I've done that throughout the course of my life. And so it's not as much about, okay, I had learned how to design this design element, this switching regulator, and now I'm going to copy that design or my knowledge of that design into every product I design after that. Maybe if I have been designing like car infotainment systems for the last 25 years, that would be the case, right? Like you start with one 25 years ago, and you're incrementally working on it and changing it, and maybe you change car companies, but you're still ultimately accomplishing the same end goal. And there's nothing wrong with that, by the way, either. That's kind of cool too, to see the evolution of something that has a particular function and you see it through the evolution. You are learning more about the functionality of that specific thing and advancing it and evolving it. And I would say my problem-solving path has been more about learning to effectively work with people in the right way and learn the kind of more product-centric set of problems and manufacturing and supply chain and distribution problems that are all far more tightly tied into the engineering now than I think maybe they were in the past, or at least that's been my experience. Or at the very least, I think you design a better product if you understand those other elements in addition to the hardcore engineering. And so I've taken things that I've learned about working with designers, working with the software team, working with the people responsible for distribution and supply chain and things like that, and applied that as I advanced through my career to get better at those things and working with those people effectively.
Right. So what do you enjoy most about working in interdisciplinary teams? And was there something in your past that you would encourage other engineers to apply in their teamwork in interdisciplinary teams?
A very important part of, I feel, me being effective as an engineer and a manager on a multitude of projects has been communicating effectively with people who are not engineers, or at least not electrical engineers, and understanding and being empathetic to the way that they approach problems. And so the thing originally that I felt kind of made me recognize that as an important thing and start to get good at it was back in college. I was a member of a project team I went to Cornell, called Cornell Sustainable Design, and I led that project team. And as part of that team, we had members from all the different colleges at Cornell. So engineering, architecture, business, industrial relations, all over the place, agriculture, arts and sciences. And the purpose of the project team was we did a variety of experiments, but it was focused on sustainable design. And we did projects around the world and also around New York State, where we were based. And these design build projects were not just about thinking about idea, but we were really executing on them. And so the engineering team might be focused on wastewater treatment, for example, and then they'd work with an architecture team that was focused on neighborhood design or urban landscaping and the design of a building that we might be designing. And that was my first exposure to working on a large team with people who were not of the same background of me. And what I learned from those people is, oh wow, other people think and approach problems very differently than I do. And at first I found that very frustrating, especially one place where we butt heads a lot was engineers and architects. It's interesting, engineers tend to take a very logical, methodical approach to a problem, and architecture is not quite the same way. It's a more nuanced, creative approach to understanding a problem and how to solve it, with keeping in mind the needs, in the case of a building, the occupants who are going to be in it and how they're going to be utilizing it. And it's just a different approach to the problem. And at first I was kind of confused by this. I didn't understand it. I found it to be frustrating and harder to come up with like a linear problem-solving approach in this way. But as I worked with these people more and more, and many of these people are still some of my closest friends, I learned that this different approach had its own benefits, and working together, I felt that we were able to come to a much better solution to the problem. And so I think over the process of doing that, and I continued in that way through my career, after college, into grad school, and into the world of work, working with people who were not just my exact problem-solving type background, and realizing that there was great benefit to understanding how these other people were thinking and approaching a problem. And I found that to be infinitely useful and helpful, and it's just as easy to complain about other people on a team or in a group that you're working with having a different opinion about how to solve a problem as it is to work with those people and come to an effective middle ground. And I have found that coming to that middle ground is both far more enjoyable and usually results in a better end product decision. And so I found that to be really important, and I've continued to learn from that and to understand it. And it's something that I think all engineers probably struggle with. I think engineers in particular, it's very easy for us to be stubborn and to think we have found the solution to the problem, and like that's the solution, that's it, and it's very black and white. And the reality is nothing is ever black and white. There's gray area to everything, and the sooner you see that and accept that and recognize that there's room for compromise, I think the sooner you're going to stop being frustrated and start getting better work done.
So in an environment where different ways of problem solving, the way you described it, are present, how can you create an environment where you can actually achieve that middle ground and embrace everybody's way of problem solving? Did you find any best practices or ways that worked out for you?
I think the important way to get different people with different opinions on the same page is to come to a common ground or common understanding about what the ultimate problem is that you're trying to solve. Oftentimes the problem, at least in the case of product design, the problem that you're trying to solve is not really how do we make this power supply as efficient as possible, or how do we make this software as elegant as possible, or how do we even make this as manufacturable as possible. Those are all goals that you want to accomplish and important parts of the product design process, but the actual overarching team goal is usually something more along the lines of how do we make this the best experience for the customer, how do we make this the highest quality product, how do we make this the thing that's going to allow the eventual purchasers of this thing, if it's a consumer good, to get what they want to get out of it. And so if you frame the problem that way and kind of work backwards to, okay, what are the solutions to achieve that goal first and foremost, then now everyone's united around kind of a more common theme, and they might have disparate, separate sub-goals that you still want to accomplish, and you often still can, but you accomplish them with the framework of achieving this end goal that everyone is in agreement on and is focused on what the eventual product or project is trying to actually solve as a cohesive whole instead of as just individual elements.
Right. But you're creating many tools kind of that enable people. Your book should enable people to create things. It should make it easy. What does it mean to you when people come back to you with something? Hey, I created this with the thing that you created.
The greatest joy of anything I work on is seeing people use it to creative ends. Opening up Instagram or Twitter every day and seeing what people have made with it since I last checked. Because now it's new things every day, and it's every time it blows my mind where people are using the tool in exciting and creative new ways and making beautiful works of art or beautiful pieces of furniture, or they're fixing something, or they're just maybe feeling excited and empowered to be making anything at all, is a very rewarding feeling for me, and I would venture to say it's a rewarding feeling for the other people on the team that I work with as well.
I think for many engineers it is that point when you actually see what you made in action. Actually, you see it working. You worked on it a long time. You solved the puzzle, and now it's working. So, what do you think? What does engineering in general? What does it mean to you?
Ultimately, I mean, at its most basic level, engineering is the application of science to solve a problem. And right, so that's the technical definition. And I don't know if I can put it any better than that, honestly. I love science. I love understanding the natural world and the laws that make it work the way it does. And the fact that we can look at those things, see, okay, this cause results in this effect, and I can use that property or that thing to accomplish some goal. You know, the fact that there's two things at a different voltage potential and then current flows. Like ultimately, like that at its most basic level results in us making microprocessors and making computers and making robots and robotic power tools, or making computers that you wear on your face. That's pretty incredible. And to me, engineering is about being able to just apply that knowledge in a meaningful way and in a different way every time. I think it's so cool that you can take these first principles of understanding, and just based on effectively what direction you aim them in, you get something else. In my book, in Exploring Arduino, I use Arduino as a mechanism to help people understand that, like, this book is not just about you follow the recipe and you get an end result. It's about, here's like a toolbox with a bunch of things, and you can use these tools to do a literally unlimited number of things. There's an unlimited number of ways you can combine these pieces of knowledge to result in an end product. And once you see that engineering is just like a toolbox of things that you can apply and combine in different ways to achieve an end result, I think that's really exciting, and that's what excites me about it. It's just limitless in the things that you can do.
Right, yeah. Literally limitless.
It is literally limitless. I don't think it's possible to put a cap on the number of things that you can achieve with a sufficient understanding of first principles of engineering and design.
I think especially in the last decades we saw really incredible advancements and variety of technological applications, also caused by things like Arduino that enabled people to create things that they put in their mind very easily. Can you speak a little bit to the enablement and platforms like Arduino, how they really bring forth even more variety?
I think this has been the constant march of engineering since it was maybe first considered a discipline on its own, which is we're constantly building upon the previous work. And so every year that goes by, there's a distillation of this existing knowledge into a way that makes it more accessible for people who are just getting into the field, right? So 30, 40, 50 years ago, you wanted to program something, you had to understand how to use a punch card, and you had to understand how machine code works or assembly code. And now you want to program a microcontroller, and you can do it in like JavaScript, which is an extremely high-level web programming language. And we have developed these layers of abstraction that allow you to accomplish extremely sophisticated things using a much more simplistic toolbox. And so every year, the level of complication that you can achieve versus the level of simplicity that you can achieve, that ratio gets more and more extreme. You can do simpler things to do more and more complex things, right? You can download a library right now that runs on a computer on the edge that's doing machine learning and running computer vision algorithms and doing all these things. And this is built on years and decades of research and understanding of these things that enable more and more people to have access to them and to implement them in their own products or projects. And so this is a double-edged sword. It's really exciting because you can jump in immediately and do really sophisticated things. And then the other side of that is you can jump in immediately and do these really sophisticated things without understanding how they work at all. And so it's really important for getting people excited about engineering, right? There's like a hello world now of machine learning, right? Where you can basically spin up a TensorFlow processor immediately and have it running a machine learning algorithm, which is incredible. And you might not have any understanding of what the hell is happening there. And that's okay to start, because if it gets you excited about the principles of the technology, then that's great. And then the next step, and the thing I think we have to be careful about, is making sure that people still understand what got us there. And I think learning how to implement the first principles of that technology is really important, because otherwise we risk becoming disconnected from it. And I think this is why understanding history in general is important, but certainly the history of technology, and in the case of software, it's great to use a really high-level language and to achieve something sophisticated very quickly, but then it's also important, and I think really useful, to understand, okay, if I want to write code on a microcontroller, here's how it works, and here's how it interacts with the registers on that microcontroller. And if I'm doing electrical design, I have to lay things out in this way or connect things to the appropriate pins that are muxed to the right functions so that the software is going to be as efficient as possible. And so once you get excited about the technology, then you can dive down, and this is what I really encourage people to do, dive down into the lower levels and understand what's enabling that incredible technology and abstraction that you're using. A, so that you appreciate it, which I think is important, but B, if you understand how the layers of abstraction work, you can understand how to implement these more sophisticated things far more efficiently and ultimately result in better quality end products.
So nowadays, it's probably not as transparent as it was back in the days. You know how technology really works. Like you gave the example of VHS player and iPhone. Could you explain that example? I really like that.
Right. So today, you want to understand how a modern piece of technology that we use every day works. You might look to an iPhone or a laptop or a television. And if you can even manage to open one of those things up, which is virtually impossible, you might look inside and you have no idea what anything does. And in some ways, this is incredible, right? Like we've achieved this ability to put a supercomputer in your pocket, and we've done that by miniaturizing electronics and developing advanced manufacturing techniques that allow us to do this and test it and productize it, which is incredible. And we shouldn't downplay those things. But when I was a kid, I would, take apart a VHS player, for example, and you open up a VHS player and it's pretty obvious what everything does. You can tell, like, okay, this is the circuit that makes the thing spin, and this is the circuit that pops up the thing for the tape deck, and this is connected to the thing that comes in from the wall, so this must be the power supply. And this is the thing that drives the display. And I'm not going to act like I am an old fogey, because I'm not. I haven't been doing this for that long. And so I know that long before I was taking apart a VHS player as a kid, long before that, people were taking apart other things and taking apart cars and building cars. And you hear the same comment from people who love working on cars all the time, right? You used to be able to get into the engine, understand what everything does. And now everything is on the engine control unit, and it's all in a computer, and it's all in microprocessor code. And you open up the engine and it looks like a toy. Like you don't know what to do there. It's covered by gigantic plastic sheet, and there's nothing for you to access or do. And it's this interesting dichotomy of we've achieved this incredible level of manufacturing automation and miniaturization that lets us make these things, but at the same time it makes us harder to get into them. And I think getting into electronics and products certainly at least for aspiring engineers, is really important to see how they work and how they tick and how they're made. So as the products that we use every day get more and more integrated and sophisticated, that may become less and less possible, and that's unfortunate, but it's a reality of the march of progress. And so for that reason, I think things like the Arduino ecosystem, for example, and Raspberry Pi and things like that are incredibly important because they still provide the opportunity to get into the lower level understanding of how these things work and understanding how you might build a product like this. And that's critical for aspiring engineers or people who are just entering the field to understand how things like this come together.
Yeah, talking about aspiring engineers, when you move through your career and through your life as an engineer, what are some things that you would tell aspiring engineers that they could maybe learn from you instead of like having to learn it themselves? If that makes sense.
Yeah.
Maybe some mistakes you made that you learned from. Yeah. Maybe some ways to interact in the workplace.
One really important thing to learn about and understand early is if you're working on a product that's going to be manufactured on a manufacturing line of some sort, which is pretty much any product that's being made in quantities greater than 10, is to spend time at that manufacturing facility, whatever it is, and to be involved in the process of understanding how that product gets manufactured and therefore designing it for manufacture effectively is really important. And it's like a whole another side of engineering that you could completely insulate yourself from if you wanted to. And I think that's a bad idea. I think it's really important to see how the products you work on get made. If you act on the assumption that you can design something in your CAD software and press a button and it shows up in the mail 2 weeks later, that's like not the reality of how things happen. Stuff goes wrong. You need to understand the manufacturing process so you can design things to be manufactured effectively. You need to communicate with your manufacturer directly. And I think recognizing that early and getting involved and into that process is important for designing better products and ultimately it should be an easy argument to make to your employer, for example, because it's only going to save you money in the long run, right? If you say, okay, I want to go to the manufacturer and be on the line while they build the first one of these products, okay, we're paying for your plane ticket, and then we're also saving the like 3 extra production runs that you have to do because they made a mistake and you weren't there to identify it as the design engineer and fix it right on the spot instead of having to go back and iterate on it over the course of the next 3 months. It's just a no-brainer thing that's easy to do and will give you more insight into the products that you're designing or working on. And I think it's really important. Part of growing as an individual is, of course, like getting better technically and learning more things, technical things. But part of it is also getting better at how you interact with other people and your personal and work relationships. And so for me, a lot of that has meant doing a better job of putting my work in context of the rest of my life. And certainly when I was in college and even after college, I was really passionate about my work, and that was great, but it could also be all-consuming. And it's great to be passionate about something, but it's also important to recognize that there's other things in life that you have to pay attention to. And making the time for that is difficult, especially if you're really excited about your work and it's something that you're passionate about. And so this is something that I still work on, which is finding the right balance. And I think a lot of people probably work on this, not just in engineering, but in any given field where you're excited about what you're doing. I think finding that balance is really important. And I think it will be an ongoing thing for me throughout my life to get good at that. And I imagine it is for most people. But finding time to set aside to be not thinking about the engineering problems that you're trying to solve or the manufacturing problems or what have you is really important for giving your brain a little reset and allowing you to come back to the problem the next day or the next week refreshed and with another viewpoint. Allowing yourself to do that is important. And I say this, I'm kind of saying this out of both sides of my head because I do a terrible job of this all the time and I get super sucked into what I'm thinking about. And I feel like if I'm not thinking about the problem or how to solve the problem, then I am not doing my job. And sometimes part of you doing your job is knowing when to stop thinking about it and then to resume thinking about it later and spend some time in the middle with your family, your friends, or just decompressing in whatever way it is you decompress and allowing yourself to come back to it. And again, I'm a total hypocrite here because I'm bad at this, but it's something that I at least recognize that I need to be better at, and I think it's important.
So what are some of the things that are outlet for you when you need to get away from things? Do you have some hobbies that you have to get away from it, or and I'm also interested in if some of those hobbies actually relate back to your profession and can kind of like add to it, even though maybe they're not directly related.
Yeah, I mean, I'll say I'm passionate about the work I get to do at Shaper professionally, but I also just really like fiddling with electronics and building stuff. Many of my hobbies revolve around the same things. I like building projects, but it's also nice sometimes to build products that aren't for anyone but yourself. So I like doing hobby projects around the house. I've been doing a lot of home automation type things. It's like just a fun outlet for me where the only customer is myself, so I can just design it for the way I want it to be, and I don't have to think about designing for manufacturing. I don't have to think about any of this stuff. And it's nice to not have to consider those things sometimes. So that's one of my outlets. I like working on those things, and those are projects that I tend to open source or post about on my website or things like that. The other outlet and related thing is working on my book, Exploring Arduino, and the second edition that just came out. That consumed a lot of my hobby time. It's definitely work, but it's work that I enjoy doing, even though it's quite similar to some of the work I might do day to day. But it's designing projects for people trying to get started with the Arduino is quite different from developing a robot. So they have their differences, and I enjoy focusing on one versus the other. Woodworking, now that I work in an active wood shop where we develop our products, I have access to tools, Shaper Origin, but also other wood shop tools. And my wife and I have enjoyed spending a lot of time building furniture for around our home and getting good at that. I don't consider myself to be an expert craftsperson, but I find it very rewarding to be able to make something and then use it in our house. It's a very nice feeling when we replace some crappy piece of IKEA thing with something that we've made out of ourselves from hardwood. And so we've been doing a lot of that recently, and I enjoy focusing on a project like that because it feels like it has a very concrete end point. Once you put the final coat of finish on that thing, it's done, and now you can use it, and I don't have to think about what's the customer support process for this thing? When is it going to go end of life? How do we start thinking about the next thing that we're going to do? It's nice to have that just concrete, self-contained project. I really enjoy that.
So do you enjoy the simplicity and the straightforwardness of it?
I wouldn't say that it's necessarily simplistic or straightforward, because I've worked on things that are complicated projects. But as much as I do like building electronics and writing software and things like that, it's nice to do something that doesn't involve either of those things. If it's mechanically complex or uses a lot of joinery, it might just be difficult for me because, again, like, I woodwork, but I'm not a woodworker, right? Like, I'm not an expert at this stuff. So things that might be really easy for someone who does this professionally is either a challenge or at least highly mentally stimulating to me in a way different from my normal work.
What is your perspective when it comes to the relationship between art and engineering? What's your take on that?
I wish we would kind of stop separating them so much, art and engineering. Humans love categorizing stuff, and so everything needs to be in a box. And so this is an engineering thing, this is an art project, this is, my English literature essay, right? I don't think it's so necessary to try to neatly categorize everything, and there's no reason these things can't overlap more. I would not consider myself an artist. I am not artistic. I am not good at drawing. I am not good at painting. I am not good at clay. I think I have a reasonable eye for design, but not so much so that I wouldn't appreciate and take the input of a designer or someone whose expertise is in that area. And I think it's important for us to consider these as art and engineering as two very complementary processes in areas of focus or study, as opposed to two things that need to be considered diametrically. I think as soon as we stop thinking about these as separate ideologies and instead just two of many parts to a cohesive whole, I think we'll be better off. There's certainly a tendency amongst engineers, especially younger engineers, past me included, to not look down on, but kind of elevate technical and engineering work above art as somehow being better or more significant or more important. And it's just not true at all. Both are extremely important certainly for designing a product, but I mean really for anything, just understanding life in general, I feel like. And I was certainly very guilty of this, especially going back to high school. It's engineering, function over form, I was really gung-ho about all this, and I think as I've evolved as a person and I've come to meet more people, and my wife is a designer with a background in urban planning and art and interaction design, and I've come to see the beautiful and important work that she does and the work that the designers that I work with do. I see how important these things are, and I've come to appreciate that all this stuff is the same, right? We're all just trying to make things. We're all just trying to have a creative outlet into the world, and whether that creative outlet is through Maxwell's equations or through a paintbrush, I don't think it's so important to consider them as being different things.
I think the name that came to my mind when you said we shouldn't separate art and engineering is Da Vinci, who was he was an artist, but he was also very much an engineer. And so, is there anybody from the past, present or future, that you would like to have a dinner with from the engineering realm?
I mean, it's unfair because I feel like I would have said Da Vinci probably. So every opportunity that I've had to meet famous people or people who are experts in their field or something has been really interesting and engaging for me and enlightening. But not to poo-poo that opportunity, but I think it's far more interesting just to meet ordinary people who are like really excited about what they're doing, especially if it's in a field that I know nothing about. And so that's actually the most interesting thing to me. So I wouldn't be able to possibly give you a name because the ideal person for me to like sit down and have dinner with would be someone who is like an expert in something in which I have no context or knowledge whatsoever, right? So as just like a basic example, I mean, I think space is really interesting and cool, but I wouldn't say that I follow like the astronomy sphere of influence very closely. I'm not reading scientific papers about cosmic discoveries or what the Hubble telescope saw this past week. So I wouldn't say I have a lot of knowledge in that area, but I find it engaging and interesting when I do learn about it. So I think someone who would be interesting for me to have dinner with would just be someone who is just like a very passionate astronomer, maybe. Someone who just discovered a new galaxy and they want to tell the world about it, and they want to tell me why it's exciting and why it's important and why this discovery is significant to humankind. I think that would be the kind of person that I'd like to sit down and learn something from.
Galileo Galilei, maybe.
Yeah, maybe.
So where do you see the future of electronics going? I mean, we obviously see a lot happening in the realm of technology and IoT emerging. We have AI coming, we have 5G.
So I categorically refuse to answer any questions related to the future of my industry because I have zero confidence that I could say anything accurate. I have my predictions in my head of where I think things might go, and I try to direct my own learning and knowledge towards things as they emerge and seem to be of significance or importance in the industry. But I think if you look back as opposed to looking forward, and look at all the times that someone tried to predict when or how something was going to happen next, they've just universally been wrong. So instead of spending my energy on predicting where it's going to go, I would rather say keep a beat on what's happening today and as new things come out. And it's hard to know when new things happen or new technologies come out exactly what their significance will be. People make predictions and people say, oh, this is huge, or it's not going to be a big deal. And I think it's too hard to know how these things will materialize. So I think just keeping an eye on things as they happen and staying up to date is really important. I try to leverage new things that I learn in my day-to-day work at every opportunity I can, and to kind of stay on the cutting edge there, and in my own hobbyist work too. But to predict what'll be the next big thing in the industry, you won't get me on tape saying that.
Right. Where do you think we are today? Because to me, I'm making the observation that technology advanced very fast. They put cell phones in our hands. Mm-hmm. They put us into self-driving cars, and we're just using the features of it, right? We are not necessarily familiar with what goes into it, and also with the IoT, we have many more devices around us that are part of our lives now. Talking about voice assistants like Alexa, Google Home. Are there any considerations that we might have to develop those things in a more sustainable way in the future?
I would say that in some ways, in terms of where we are today, I'm a little worried about the proliferation of, I don't want to call it Internet of Trash, but sometimes it feels like it. There's a lot of things coming out every day that have features that may or may not connect to the internet, but automate parts of our lives in new and interesting ways. And I think that's really cool, and especially as it allows people to kind of flex their knowledge and learn new things and get more people working on these kinds of products. That's exciting. I worry about us making too many things that serve one function that's maybe not something we needed, right? Like, I'm sure it's only a matter of time before an internet-connected fingernail clipper comes out and it's giving you stats on how many times you've clipped your fingernails, right? Like, it just seems like that is a plausible thing that could exist in the world today, right? At the rate that these new products are coming out. And I do worry a little bit about the sustainability of this, We got IPv6 now, so that's good. We're not going to run out of IP addresses. We got 5G. Everything's going to be connected. Okay, cool. So like, technically, can we support all this stuff? Yes. Should we? That's a more philosophical question. As someone who I would consider myself to be very tech savvy, early adopter, bleeding edge, I like all this stuff. I find it interesting and engaging to use it and learn about it and leverage it in my life. I do worry if we're going to get to the point where we have too many things and they're all connected to the internet, and what does that mean for our privacy, and what does that mean for sustainability and environmental sustainability in terms of the production of these things, right? Like, are we designing products that are going to last us for 10, 20 years, or are we designing products that are going to track our fingernail clippings for the next year, and then the built-in battery is going to die, and then we're going to throw it in the trash, right? And then we're going to buy fingernail clipping tracker 2.0 next year. What does that mean for us as a society in terms of how we treat our physical goods, and what ends up in the landfill, and how we effectively recycle things? And as more and more things have batteries and we have limited resources, where is all the lithium coming from, for example? Like, this is not something that I would consider myself to be a subject matter expert on, but as we make more and more things and they use more natural resources, we have to be really cognizant about how those things will eventually be recycled, or ideally upcycled into something else later. And as we make these more and more tightly integrated things, pulling them apart afterwards and recreating them into something else becomes more and more challenging. And so it's definitely something I worry about. And I know it's I don't mean to be pessimistic on the current state of where things are. I think it's a more exciting time than ever to be an engineer and to be making things. And the world's your oyster, which is awesome. And I think that's phenomenal. And I just want to make sure that we do it in a way that's sustainable, so that in 20 years, the next generation of engineers still has the resources or the environment in which they can be making the next generation of incredible things. And I think that there's a lot of products that are a solution in search of a problem. And that may be fine and cool from the perspective of building something neat. Like, I am all on board with having an idea and just making something because it's cool. I do it all the time. I do it for personal projects. But I think it's just important that we as engineers try to be measured in building solutions in search of problems when it comes to mass-produced items, and the impact that those things have on the supply chain and the environment that we're using them in, and what their end of life will look like, because all these products are going to have an end of life eventually, and where do they go when that happens?
If you talk about IoT devices, you also talked about security before.
Mm-hmm.
And so there's that's probably more on the consumer side, is it worth the IoT device to produce the trash or to sacrifice security? Like you, before the interview, you mentioned to me the connected door lock.
Yeah.
Is it worth it?
Everything in life is deciding on risk trade-offs, right? With any new product we use, long before there was the Internet of Things, there was, okay, do you want to trade off some amount of your privacy to get X free service, where X free service is Facebook or Gmail or any of these things that you do not pay for, but because you are the product, right? You're being advertised to. And they advertise to you by understanding some of your personal information. And you might do the math and say, I'm okay with them having that information in return for the benefit that I get from the product, right? So I use Gmail. I love Gmail. I think it's a great product. I'm sure almost everyone watching this uses Gmail. And you get advertised to by Google because they understand personal information about you from your use of your Google account. And I did the math. And for me, I am okay with the amount of personal information they have about me in return for the benefit that I feel like I get from the product. And I don't know if everyone thinks about the things that they buy or use in that sense. And I think we maybe need to start instilling that in people, not just for digital-only products that live on the web, but now for hardware products too, right? You might buy a product that's connected to the cloud, and if that company goes under, that product might stop functioning, and now you have a paperweight. You might buy a product that is a camera for your house or something, and anything is hackable, right? With enough energy and resources. And so is the trade-off of the convenience of having that thing be easily accessible to you worth the potential security implications? And I can't answer that question for you, and that algebra is going to be different for every person. I certainly struggle with that question. Like, I love new technology. I want cool gadgets and gizmos. I want them to do cool things. I want them to be connected to the internet. Like, it seems useful and fun. And I struggle with this question all the time, and I don't know the right answer. And it's the same as with like elections. Like, you ask any security person, like, are elections secure? Like, no. Anything that happens digitally, like, it's not secure. Like, assume that anything that happens over the wire is like hackable, right? And so they'll say like use paper. So if security researchers, the people who might build those systems, right? Like the people who we would hire to build like digital election systems say, oh my God, you want me to build a digital election system? You're insane. And like, these are the computer scientists who like write secure software, right? Like they recognize that there's always going to be security vulnerabilities in everything. We saw it in the last couple of years with x86 processor architectures, right? Like, there's always going to be something. There's always going to be vulnerabilities, and as things get more and more complex, the room for not necessarily error, but just holes in things increases, right? Like, there's more people touching these things. There's more layers of abstraction. Things get missed. And you know, I don't think we're going to solve the security or encryption problem permanently. Maybe we will. That would be incredible. But it doesn't, certainly from the data we have today, it doesn't look like that's happening anytime soon. So instead, you just need to understand that the risk is out there and just, you know, be careful about the products you use and what kind of data you put in them.
So is there anything that we missed in regards to advice that you might have for aspiring engineers, for other engineers, for fellow engineers?
My book is used as a textbook in a lot of colleges, and so I've been asked many times, like, advice for people or things that I learned that I wish I knew earlier, maybe. And the one thing that frequently comes to mind is actually an economic principle, the Law of Diminishing Returns. So the Law of Diminishing Returns in economics says you put more and more investment into a thing, and past a certain level, the return that you get per increment of investment decreases, right? So you put in 1 unit of work, you get 1 unit out. You put in 1 unit of work, you get 1 unit out. Once you get up to a certain point, you put in 1 unit of work, you get half a unit out. You put in another unit of work, you get a quarter of a unit out, right? Like, over a period of time, the output that you get from investing into something is going to start to level off asymptotically. And so the advice that I give is to apply that to their life in academia, specifically as it relates to their courses. Odds are, in a given course, or at least this was my experience back in college, you can put in 20 hours of studying to get a B, or 25 hours of studying to get a B+, and then like 40 hours of studying to get an A. And at some point in that curve, you need to say, okay, maybe that extra 20 hours is better spent on a project team, or working in a research lab, or even just being social within reason, as you know, college can be. I would say I didn't truly figure this out until like maybe my sophomore or junior year. And what I came to realize was I was spending a lot of time studying for class. And in many cases, I could spend a little bit less time studying for class, still understand and absorb the material, maybe do a little worse on the test, maybe a little worse on the problem set, and instead engage that extra time into, I spent lots of time working in a research lab where we did machine-inspired robotics. I worked on this project team, Cornell Sustainable Design, which is where I got the opportunity to work with an interdisciplinary group of people that was extremely formative for me in helping me to understand how I want to approach the world as an engineer. And these experiences were, far more useful for me than, no one cares what your GPA is after college. Like, if you passed and you did reasonably well, no one's gonna give a damn if you had a 3.8 or a 4.0. It does not matter. What's far more interesting is to look at your resume and see, okay, they did all these projects. You know, I came out of college and I had a website with, you know, 20 different open source things I had done. And that was far more interesting to potential employers than, oh, you got an A versus a B+ in this analog design class or whatever. The fact that I was engaged in what I was doing and was learning outside of the classroom is far more important. So that's an important piece of advice I would give to anyone who's starting their kind of engineering journey.
Well, thank you very much, Jeremy. it's been a pleasure to be back in the workshop here and to see you again. And I thank you very much for your time.
Yeah, thanks for having me.